Hello. Welcome.
Hello.
Welcome all to another episode of, what do we call ourselves? Beyond the Algorithm with NVIDIA. That name's pretty long, but it sounds pretty cool. But we're back again this week with one or two familiar faces. We're going to be talking about multi-LLM NIM in this live stream, simplifying deployment for the world of LLMs with NVIDIA NIM.
Woohoo.
Yay. Before we get started, though, I wanted to go through a couple of housekeeping items. The first off is, I will share my screen. Sigraph is coming up. And where is this, you ask? It is in Canada. Where in Canada? It's in Vancouver, BC. So for all you Canadians, Pacific Northwesters out there, if you have time, come by. It's in about a month or so, August 10th to the 14th, Vancouver Convention Center. I don't know if you can see it. It's really tiny, but I'm going to put it in the chat, the link. I'll also share it with people on our other platforms. And you will be able to see a discount code for $50 off a regular registration pass, but also a free exhibits only pass. So if you want to see the exhibits and your wallet's a little light, really light, you could use that code. I think it's, if I can read it, NVID1348. Don't tell me who came up with that. It wasn't us, but it still works. So I think that's all good. It's valued at $50 too, so something that would be great for the community. Oh, somebody's going to be at Sigraph. Yay. Thank you. Anybody else? But yeah, so just wanted to share that with you all. Thank you again for joining us. The community team is really trying to work hard to get more engagement. Everything from this live stream with Chris and Bethan to all our other teams and products, office hours, and beyond. So we appreciate you joining us. Stick around to the end because there is a surprise I wanted to share from our community team, mostly Joe and Marcus, who've been working on a project for a long time, and I think you will like it. I will share it towards the end, so please stick around. All right, so today, we are here with Chris, who you probably have seen with some other people on the stream. He's got like this rotating thing where his titles always change because he's so good at everything. One day he could be like, master astronaut or pilot, Air Force, so-and-so. But, he was deep learning in the past, but his current title is product research engineer. So Chris, we try to keep up, but it's hard. So you need to maybe slow us down a little bit. Also, first time joining us is Beth Ann, who is a product marketing manager for enterprise software products at NVIDIA. So give Beth Ann a big welcome. And, you can just wave to Chris. We'll be good with that. But again, this live stream is for you guys. So please, questions. We want them. Drop them in the chat. If you're on LinkedIn, if you're on X, we actually started streaming on X recently. And we should be there now. We are live there. Oh, yes, we are. And LinkedIn, please drop your comments, ask questions. If we don't get to your questions, it's not that we don't want to answer them. We have limited time, and please join, our forums, developer Discord. We'll put the links in the chat to continue conversation afterwards. So, I've done enough talking. I want to hand it over to Beth Ann and Chris. So, guys, can take it away.
Awesome. Thank you, Zach. Really awesome to be here. I love this crew, and I love the live streams and our audiences that join us from around the world. So thanks, everyone, for being here. Happy Thursday. Hope everybody's having a great day so far. So we're here today to talk about the multi-LLM compatible NIM. This is a new option for people who are deploying the latest AI models with NVIDIA NIM. Just quick reminder to everyone, like, what is NIM? NIM are basically like containerized GPU accelerated AI model servers, and they're production grade for AI inference. And since NVIDIA launched NIM about a little over a year ago at this point, our customers and partners, they really like how NIM helps them streamline model deployment. A bunch of different AI models. You just deploy NIM containers on Docker or via Kubernetes. There's nothing to stand up or configure. They just run on NVIDIA GPUs, whether that's in the cloud or in your data center or your workstation. And basically, they work the same way every time. So people who are trying to build a lot of AI capabilities and use a bunch of different models really like that, because it just kind of simplifies a lot of the hard stuff that you typically have to do when you're standing up inference servers. So until recently, every NIM that NVIDIA provided was specific to a given model. So in other words, each NIM came with an optimized model that NVIDIA builds in our NIM factory. And that takes a little time to do that optimization. And a lot of our audiences are saying like, hey, we want more NIM for more models. So we're continuing to build those model-specific NIM. And in the meantime, we have this new NIM. And again, it's the multi-LLM compatible NIM, or just the multi-LLM NIM. And it's designed to be used with a bunch of LLMs straight from the community. And we're covering right now like around 50 different model architectures. And that amounts to like over 100,000 public and private variations of models that are hosted on Hugging Face. So basically, you just run this multi-LLM NIM with the input of your LLM that you want to deploy with NIM. And then the NIM container analyzes the model format. It analyzes the architecture and pairs it with the right inference backend. Everything's included. We have vLLM, we have NVIDIA TensorRT-LLM, and SGLang. So it does all that analysis, and then it just starts serving your model with an API endpoint. We have a lot of enterprise customers who are already adopting this, folks like SAP, like Cloudera, many more. But the point of this today is to stop talking and sharing slides and just show you how this works. So Chris, so great to be here with you today. And I know that as a product research engineer, your current title of awesomeness, you're building a lot of NIM capabilities, all the time. So very curious to get your take on this. Like, why is this helpful for you? And then go ahead and kick the tires for us and show us how it works.
Yeah, I mean, I think you've covered it very well already, which is the idea that we don't need to we don't need to spend as much time fretting about things like the back end, which is not just due to performance, right? So obviously we want to always be able to select the most performant backend for our system, but also it's this idea that I want to be able to test this in whatever bespoke application that I use, either specifically for testing or just to play around in. And having that unified interface through the NIM is really helpful, because I don't have to change the way that I'm addressing this container. I don't have to change anything about how I set things up, or find a different flow to figure out how to do tensor parallelism in vLLM versus SGLang versus TensorRT-LLM. And I think this is the kind of thing that really brings it all together, is that it's just one container every time. And then the guts change, but that translation's being handled for us. So, of course, there's side benefits to this, which is it's the same container that you're going to test in, that you're actually going to then move to some kind of prod environment. So let's say, for instance, you want to do some quick experimentation, and you prefer, to not worry about perf at that moment. You're just wanting to get the model to run. That's fine. And then when it comes time to okay, now we're going to profile the backends. We're going to see which of the available backends are actually fastest and which setup is fastest. Again, you can do all of this in one experience, as opposed to kind of, all over the place. And so I think that's really,
right.
As someone who's building with models a lot, this is what excites me.
Totally. And I think we're going to be building even more intelligence into the container over time. So instead of like having to do that kind of quick experimentation to see which backend you really want to deploy it with, we're going to have that intelligence built into like it'll know the best performing one and just automatically deploy with that backend. So super exciting stuff ahead as well.
That's even better. Yeah, of course. You know, even less thinking that I got to do, which more time building. So there you go.
Totally.
So I think we've got a demo that we want to kick off. So guys, right now, of course, the live demo gods have smote us this day. And so we're going to be able to do some component of this demonstration live, but not all of it. So we luckily already recorded a demo, you know, in the past that we'll walk through. So if if you think it's right, we'll do that.
Let's spin it up. Too bad, demo gremlins today. Boo.
Yes. All right, Zach, if you want to pull up the demo onto the old screenerino here, and we'll get into it. I'm gonna pause the demo. There you go. Go ahead. Sorry.
Minus the water.
Yeah, it's no water.
Let's see who got that.
What's up, everybody? It is Chris Alexiak here,
That's
Private
me.
Research Engineer at NVIDIA, and today I'm excited to talk to you about a single NIM container that can run a broad range of models, right? So you may have heard of different inference backends like TensorRT-LLM, vLLM, SGLang, right? All different ways that we can do inference with these models. This is a single NIM container to bind them all. The idea is that you don't have to worry about what backend is supported by what model, et cetera, et cetera. This NIM is going to help you launch those models with relative ease. So how do we actually use the thing? Well, it's pretty straightforward. Basically, we're going to export our NIM image, which is going to be LLM NIM. Once we've done that, we're going to go ahead and export our Hugging Face token. This is because we may want to use like a gated model, right? So we first request access on Hugging Face, and then we would download it in our local environment. Once we've done that, we have one last step, which is going to be to create this NIM cache in our present working directory. And what that does is it allows a place where the model's weights can live, so that if we want to launch these NIMs in the future, we don't have to like re-download them each and every time. I've already gone ahead and done this, so we're going to see that error, but that's totally fine. Once we've done those three steps, right? So we exported the NIM image, we exported the Hugging Face token, and then we made sure that we had the NIM cache, we're actually good to go. You're going to see this Docker command. Mine's going to look a little bit different than yours, right? But the idea is basically, we're going to run this on the third GPU of our environment. We're going to have the shared memory size of 16 gigabytes. We're going to do some kind of Docker bookkeeping here, again, pointing to this NIM cache, which we've created, right, to store those weights. Make sure we pass in our Hugging Face token. In this case, because we're using one GPU, we're just going to set tensor parallel size to 1, and then we're going to point to the actual model name. So we're going to be...
So I just want to pause right here at this moment just to kind of walk through, the idea of our, this command, right? So basically, like, this is the way that we interface with this system. So there's no other kind of, work that we need to do when we're using this NIM, right? So you're going to see that we use these environment variables for everything. So in this case, like, we have our tensor parallel size, right? And this is going to let us choose what level of tensor parallelism we want. And all of this is done through those environment variables. Like, one of the things that's really nice about getting spun up quickly with this is that you don't have to learn like a bunch of 8 different APIs, right? You're just basically looking at the doc, seeing what environment variables are open to you, and then you can pass them in as you spin up this container, which is something that makes it just a little bit easier to use. And also, again, like, these are all environment variables, so you can have these set in a config, right, that we just pull from whenever we use the system in order to make sure that it's spinning all the containers up like the way that you prefer, the way you want. But I just wanted to pause there and show like all of these -e's, right? This is like how we change stuff about what's happening in this single NIM.
Using CodeStrill22B v0.1 for this, and then we're going to expose the correct port and then make sure we're pointing to our NIM image. That's all we have to do to get started with this NIM for LLMs that, again, is going to dynamically select available backends. So I'm going to let this thing load up, and then I'm going to come back after it's loaded, and we'll show you how long it took, and then we'll go from there. All right, we're back. As you can see, this thing is up and running. And again, we didn't have to do anything other than that Docker command. And you'll notice that it didn't take very long at all. So we're just going to scroll up here to see, just how long it took. It was 18 seconds to actually load that graph. And that is really about it. So everything else that happened, 2.6 seconds, 6 seconds for loading the model. These things happen very quickly once we have the weights downloaded. Obviously, if you're downloading the weights, it's going to take a little bit extra time. The next thing we're going to look at is, how can we determine what backends are available to run our model? So let's go ahead and jump into those commands now. All right, so now what we want to do is we actually want to see, what profiles are available for, let's say, Llama 3.1 AP instruct, right? So this is the same style of Docker command. We're pointing to the specific GPU we want. We're exposing the ports we want. But we've made an important change, which is that we're including this list model profiles configuration as well as pointing to that model. So what this is going to do when we run it is it's actually going to use the LLM NIM container, right, to figure out what backends are available so that we can then decide which we want to use depending on, a number of different factors that we may like or dislike about different inference backends. So you'll see that this is going through the same process as what we saw before.
And so, like, this is kind of like the big part, right? So if you're wondering which is like the most important part of this service as it stands right now, this is it coming up.
The only difference is that instead of spinning up the LLM NIM at the end of the day, it's just going to tell us these profiles. So you'll see that we have a vLLM profile, a TensorRT-LLM profile, an SGLang profile, as well as LoRa profiles for each of the available engines.
And so this is something that's that we don't talk about in this demo, but is important to highlight, which is that we actually have the ability to select which profile when we're spinning things up, right, through the use again of those environment variables. So it's not like this isn't just for funsies that we're showing these supported backends. It's actually going to be what lets you choose which backend to use. So you'll also notice, right, we've got a bunch of different profiles, even for each of the backends, right? So we have our LoRa profiles versus the regular profiles, and again, everything that we're doing basically is informed by this these profiles. So we get to choose them whenever we'd like, and what I was saying before about choosing like the best one for a use case. It's as easy as just trying out the different profiles. Beth Ann's saying maybe it's going to be even easier in the future, right? Which is, hey, it's not bad. So we'll let past Chris continue going on.
So this is one way we can check to see if we have available engines. Let's look at an example that has fewer available engines, which is going to be this Lava 3, Lava Next 8B. Again, it's the same Docker command, right? Nothing's changed. We're giving this the same style command. We're just using this list model profiles and then pointing to the model that we care to find the profiles of. It's going to go through the same process as we just saw, of course, and what it's going to tell us at the end is what backends are available. You'll notice here that, this is aware of what GPU or hardware you have, right? So it knows that I've got an H100 80 gigabyte. And then you can see here as well that we only have an SGLang, compatible engine. So when we spin up this NIM, it's going to go ahead and it's going to make sure that it's selected that, specific backend that is compatible. What we're going to do now is explore, what if we had like an AWQ quantized model like you see here. So this is the Qwen 2.514B instruct with that AWQ, quantization. Well, again, because this NIM is able to determine which backend to leverage, when we go to spin this model up, we're actually going to select a compatible backend with this checkpoint. And that's the whole idea, right? Is that it's just made to make things a little bit easier. Make sure that you've got the correct backend selected when you go to set things up. We're going to go ahead and let this thing load and come back when it's finished. And we come back and see.
And it works, of course. Of course, it has to work. Yes. The idea it would mean nothing if it didn't work, right? If you could do inference with the model, so of course it does. But one of the things that I think is important to point out there is that we have this idea that it's not just like base models. It's not just X, Y, Z model, right? So it's as long as one of the compatible backends can run this thing, then the NIM container can run this thing. And that's the kind of point, right? So like Beth Ann said when we started out, it expands hugely the pool of available models that you can test now with that same unified interface. And that's something that really is quite quite advantageous. And when we think about what we want to be true in the future, right? Like of this kind of container, we don't have to change our app. We just spit out the new kind of NIM, right? And it's gonna work automatically, which is the best. So and the rest of the demo was just that it worked. So we can go ahead and waylay that. Michael, so demo Chris is a different guy than current Chris. So I'm currently talking into my microphone. This guy recorded this in the past, so that's why you're seeing that audio difference. My many apologies. It seems like the video was a little bit quiet, but all this guy is saying is that we can spin these things up quickly, and we don't have to fret so much about what the actual models are, which is quite a bit better than before. There you go.
It's pretty cool. Pretty cool having two Chris's.
Yes. Thanks, past Chris.
I haven't decided which one I like better. I think I definitely like them both.
Okay. There you go. Well, it is what it is. But yeah, so I think that's the basic idea with the NIM. Yes.
Hey, Chris, we had an ask from the audience if you could tame your mic a little bit.
Yeah. Hopefully it's a little bit better now.
That's it.
And we're better alignment with
level unlocked
with demo Chris. Yes.
Now we have demo Chris. We had a different Chris a few minutes ago.
Yes. All right. Yes. So that's basically the demo on how we can kick these things up and how we can change things. Insofar as what we want to do otherwise, with these NIMs, I think we have a plan to look at some developer example that we have. Beth, and if I'm not rushing us, I think that's where we're schmoving to.
Yeah, let's bring that up. Show folks how they can quickly get started.
Yes. Okay. So basically, we got a sweet blog that you can look at. So I'm going to just go ahead and start sharing my screen here, and I'll also open this little app. And yes. And basically what this is it's our blog arena on this particular multi LLM NIM, which is pretty dope. There's that video if you wanted to watch it again. All the instructions are available here, guys, right? So everything that you want to do to spin things up, all of the profiles, any information you need to spin up specific profiles, right? I'll just zoom in a lot so you can see it better. This is again, everything through environment variables, right? We're not having to write any code. We're not having to do anything outside of the ordinary. We just need to use those environment variables to do everything. We also have this developer example, right? So this is our basic. The basic idea of the example is that we have this, again, unified workflow. What unified workflow means here is just that we have this ability to, again, ensure that we're selecting the correct backends with NIM, making sure that we have the ability to launch our model And again, this is all going to be handled for us. So what this is what's called a blueprint. So the blueprint is basically a setup where we can just launch this and deploy it. We don't have to worry about it. It's production ready. It is instead of being like a code example like you might be used to, this is a ready for prod example, right? But it's not just ready for prod and then it's like a fixed in, locked down example. It's called a blueprint for a reason, which is that it's meant to be built off of, it's meant to be expanded on, it's meant to be changed and modified. And this is the idea behind these blueprints, right? Is that they're supposed to be flexible for you, and the idea again is that this is a jumping off point. You can start here and stay here. Listen, it's ready. It's ready for prod, but it's meant to be expanded on and taken to tailor fit your needs. But again, this is what we're doing. It's the same thing as before, where we're going to be able to pull our NIM. We can deploy whatever model we'd like. We can test that model, and we can do this all from the unified interface, right? So again, when we move the NIM around, right, all we have to do is so as we choose new models, all we have to do is choose new models. There's no more programming that needs to occur from our point of view, which is kind of I know I'm belaboring a little bit, but that's the point. And so I have here like an example application, right? So we have a NIM that uses a Olama Nemotron Super 49B. We can say things like, detailed thinking off, just because that's what we want to do, and say, what is, I don't know, what is the color of water? And excuse the red squigglies. This is because the autocorrect doesn't understand Canadian. But the idea is that we have this, ability to test this model. And then if I wanted to, make a change, what I can do is on my back end here, all I'm going to do is I'm going to actually point to a different model. And again, this is I'm not having to do any coding here, right? I'm just pointing to a different model for a different NIM. This is the benefit. So the application is going to remain exactly the same, right? So instead of needing to work our butts off, let's say, right, to choose a new framework, or to rely on some intermediate layer, yada yada yada, right? We're gonna instead just be able to restart this, and we should be good to go. I'm just gonna make sure that I do so correctly, and boom, we run it, and then we can do the old refresh Reno, and we're just going to wait for the backend to boot up. But the idea is, again, we don't have to change any of this stuff. We don't have to change any code, right? Our front end is exactly the same. No code changes. All we're changing is, specifically like references, right? So we're pointing our endpoint at, right? And so again, because NIM works very well with the OpenAI API spec, we can just use the same thing every time for every app. I know it's like, I keep repeating this phrase, right? But that is the benefit. I mean, that is the thing that's good. And then again, we don't have to sit here and be like, oh, do we have to change our app to get the best performance? Or like maybe in 2 months, like someone comes out with TensorRT-LLM comes out with like the best inference backend anyone's ever seen in the world. And we're like, well, we've got to take advantage of that, right? We want our app to be the best. We don't have to redo it. We don't have to change things. We don't have to restructure our whole, API interaction backend. We could just use the new model, and that's or the new backend. And I think that's the advantage, right? Because we we talk a lot in the, like, I know when I'm talking to other people who like to build stuff with LLMs, we talk a lot about the ability to change models easily, right? But we don't really talk about changing backends easily or changing inference software easily. And I think this is the gap this is filling today. And if you, so the link to the blog I can drop in the chat. And then, of course, the developer example is available on build.nvidia.com, but also it's available as a repo, right? And we can come into this. We can do whatever we want. This is ours to use. All of this is for us. We don't need to do anything but run it. And this is, again, super low requirements. You just have to have enough GPUs to hold your model, and you have to install Docker with the NVIDIA container toolkit. That's it. That's the amount of prerequisite that you need to do. And again, if you have been someone who's like, I've heard of this NIM thing, but I don't have 8 GPUs laying around, right? Like I'm not GPU rich. I'm GPU poor like the rest of us, right? Like we can run smaller models, right? We can run, let's look at the example here, right? Is a very small model, right? The 0.5B. We don't have to worry again about like having 8 GPUs. We can just run the small models right through NIM now, right? And I think this is relatively close to as they come out, right? Which is something that's great as well. Anyway, I've been blabbing on it for a little while, so maybe we can take a question or two or something. But I'm just excited about it because it just makes things a lot easier.
Awesome. Yeah, Chris, take a look through the questions. I've been trying to answer them as we've gone through, and want to apologize to everyone. There's kind of a character limit in the responses, so sometimes the links got cut off. So apologies for that. Hopefully we got them out there to you.
Yeah, we're trying to post the links in separate chats so you can get the entire and doesn't get truncated.
Yes.
There's quite a few questions in the chat. Let me star some. Let me tag some of them, and then we can go through and see if.
Heck yeah.
Hang on a second. Apologies, it says running quite quickly.
Yeah, but like, for me, like this kind of thing, right? This is what I'm talking about. Just switch the backend. Love it. Does the model have to stay in VRAM even while it's not being used? So as long as you have loaded the NIM, as long as it is running, it is using GPU memory. So if you have 0 requests, but the NIM is running, it is using GPU memory. If you have many requests while the NIM is running, it is using GPU memory. It does use more GPU memory when it's under load, of course, but there is some baseline that holds the model weights, and this is going to be consumed by the GPU while it's running. Yes. Oh, yeah. Okay, so great question. Can you deploy to local Docker container, but point it somewhere in the cloud to use a lot of GPUs? How do you do that? So basically, we just run this wherever all those GPUs live, right? So we deploy our NIM wherever those GPUs live, and then we can hit that OpenAI API compatible endpoint, the NIM endpoint that's spun up on those resources from wherever we have access to that. So that's actually how I do it. So I in my house, I don't have tons of GPUs. I got a few GPUs, okay, because I'm a fanboy, but I don't have a lot. And so I'll SSH into a machine that has 8 A100s, and then I'll spin up the NIMs, and then I'm able to hit them, as we just saw, through the through this workflow, right? So yes, answer to the question is you can deploy these remotely, and then there you go. Another question: have you tested with Kubernetes or OpenShift? I think this is probably a Beth Ann question in terms of our are compatible?
Yeah, NIM is designed to be deployed via Kubernetes and auto scale on Kubernetes. It has inside the container we have the GPU operator, all that great software stack that is designed to make it easy to just run on Kubernetes, accelerated on GPUs. So all of that's just built into the container and there for you. And definitely check out the documentation. That's where we have the deployment guide. We have a lot of content in there that talks about the different platforms where NIM is supported. We have Helm charts. We do have NIM supported in Red Hat OpenShift, and there's a lot of blogs out there on that. So absolutely, built to scale on Kubernetes. What else do we have here?
And we are live. Just to say, so Tyria asks if we are live. We can even respond to that question, proving, I think, that we're probably live.
Are we? Are we live?
Yeah, I think so. I hope so. It's gonna be a weird dream, man.
In the future. Yeah, there are a couple of other questions, but then I don't know if you want to. Yep.
Oh, yeah. So how much control do developers have over underutilized resources compared to auto-assigned ones during prod inference? Again, I think this speaks to the question that Beth Ann just answered. This is very flexible. You have a lot of control here with things like operator. We have a lot of really effective and easy to use scaling options that are kind of powered by Prometheus and things like that. Like it is something that allows you to scale into the resources that you need to use. Obviously, there's some minimal, kind of resource cost, but that's going to be persistent. But it is meant to be able to scale with your needs and your volume. And Beth Ann, you can add context that I've missed.
Yeah, no, I think we pretty much covered that one, and definitely there are different deployment options, including what Chris just mentioned, the NIM operator. That's another software tool from NVIDIA that is designed to provide even more control and ease for deployment, and then managing the workload once it's in production. So definitely just Google like NVIDIA NIM operator. I'll find a link and drop it in the chat as well. Here's another one.
Yeah, what is the main difference between NIMs and something like Olama models? So it really depends on what part of the deployment journey you're on. Let's call it that, okay? So like for quick, local, iterative development that doesn't require, that's not sensitive to performance. I think like something like Olama is still pretty good, right? Especially if you're looking at using these hyper quantized models on CPU or on your Mac, right? Like for local development, like Olama absolutely, has a niche there. But when we're talking about moving into that production environment, we're talking about leveraging GPU resources. Like this is where NIM's going to shine. So it getting things set up the first time, it may be a particular workflow that might take you a little bit, right? So maybe it's going to be like, instead of like the 5 minutes, it becomes, once you've got everything set up in your environment, right, you might be spending like 20-30 minutes getting things prepped. But once you've done that initial setup for wherever your resources live, like it's so quick to spin these things up, especially if you're using cached models, right? So one of the commands that we looked at but didn't really talk about a lot was this idea that there's a cache where we, of course, are going to leverage we're going to save the model weights, right? But this is kind of like NIM is when you're ready to scale into kind of that production use case, like that's where it's going to shine, versus something like Olama, which is really effective for like fast, local, iterative development. With small models available on NIM now, though, I mean, gap's closing a little bit, except for the GPU part. The GPU part is still super important. Olama, famously loved by Mac users. There's no GPU. It doesn't. Olama don't care. The NIM still looking for that GPU hardware.
Thanks, Chris. I'm going to take this one. I think this is such a good question, and we get questions about this all the time. So basically, the GPU requirement is it depends on the model. And we are working on building some tools into the build.nvidia.com experience, and also kind of command line tools that will make it easier for any given model just to quickly understand what the GPU requirement, the minimum number of GPUs, and the memory requirement. So yeah, short answer is it depends, but we're going to try to make that easier for folks. There's some math behind that, and it just depends on the model. And anything you want to add, Chris, of course, obviously feel free.
Yeah, I mean, it does work on 4090. Again, it kind of comes down to profiles that are available, right? So I would make sure you're checking your profiles that are available. Especially for more GPU sensitive or hardware sensitive backends, like it can be important to make sure that it's available through a provider that does support it. But I would say like this does work on my 4090, and once you have it set up, once you go through the CUDA setup and the container toolkit setup, which can take a little bit, especially if you're on something like Windows and you're trying to use the Weasel backend, it's definitely something that can be done. And once it's done, it's very pleasant, right? Yeah.
Cool. I'm just kind of scrolling through the questions. I feel like there are some newer ones, but we kind of answered them already in the other questions. Let's see. Not sure I understand that more recent one.
Yeah, so the math can account for KV cache. So does said math account for KV cache? Yes, I mean we can set the size of the KV cache. So this is all just mathable stuff. Again, we get to choose that through these environment variables, in fact, and that's something that again makes this more accessible. Instead of having to like fight through random APIs, it's cleanly exposed through an API, through an environment variable that you can find in our documentation.
Cool. There's another one here on cost efficiency and data center scale inference. Definitely want to. I think we've done a live stream on NVIDIA Dynamo. Zach, do you recall?
Yeah, we did. We have two, I think, Dynamo live streams that we did. One office hours last week, and
oh, cool.
There was another one before. Let me dig up the links and then I'll post them in the chat.
Yeah, I think this audience might appreciate some tips to learn more about Dynamo. That is a new NVIDIA open source data center scale inference solution that delivers disaggregated serving and KV cache-aware routing. And those capabilities are going to be coming to NIM. We shared that news at GTC this past year, and later, soon we're going to be building those capabilities into NIM as well. So anyone interested in the data center scale stuff and the fancy disaggregated cache and KV cache-aware routing, definitely want to keep an eye on. Learn more about Dynamo and stay tuned for more coming from NIM. Thanks, Zach.
Yeah, I just put the links in the chat. Two of them. One was from our office hours last week, and the other one was, I think, just a talk from both Kyle and Harry about a month or so ago. And the team is working hard to put together another Dynamo office hours. So stay tuned for more community stuff. This live stream, yes, it will be available after the stream. Let me put the link into the chat. Everything that we do on the developer team, community team here, when we host live streams, they will all be living here in this link that I'm sharing in the chat. Or you can just navigate to NVIDIA Developer YouTube, and there's a couple of tabs at the top. It says Home, Video, Shorts, and there's a Live tab. Just click on that Live tab, and you'll see all the videos recorded there, and you can watch to your heart's content. And also, I think we've been posting in the chat, but if you've missed it, just scroll up. We have our NVIDIA NIM developer forum. If you want to ask and post questions to Chris or whoever else, Beth Ann, we'll have teams monitoring those channels. We also have our developer Discord, which you can then navigate to a channel with NVIDIA AI Foundation models, where you can, post more goodness and learn about what's happening and talk to the community.
Yeah, and these have been such great questions, and also just folks saying hello, like love the engagement. Thank you so much. And welcome anyone. Just find me on LinkedIn, send me an invite. Would love to stay connected and continue to help as you all play around with NIM and hopefully start deploying it in production.
Yeah, great. Well, we had a good time, and I did say stick around to the end. There's something I wanted to share with you guys. So if you haven't seen it already, our community team, led by Joanne and Marcus, have launched our community hub. Yay! So everything and anything for all developer community. We posted our upcoming events, like this one that we're doing today here. We have a few others coming up. We have our Nemo Retriever live stream. We also have a developer showcase that we launched yesterday that features work from, I think, some people in this chat. I recognized, I don't want to say names, but I know who you are. Starts with a B, I think. But, all the projects, especially those who have won, there's Clara here. There's Agents of Inference, wink, wink. If at any time, we get a lot of questions about where do I start? How do I build something? This is a great resource to go to get ideas, to see what your peers are building, and how you can either mimic, copy, make it your own, and learn. That's what these two, resources pages are all about, learning, connecting with each other. So I think we're going to end it here today. I want to thank Chris and Beth Ann. Thanks for joining us. Chris, you're always full of energy. Maybe you can come and work with us a bit more. I know you're coming back again at some time. So really appreciate.
I'll make sure too that I'm beta Chris from the start. No bad mic, guys. Many apologies. You had to bear with that. I'm glad Demo Chris had his audio figured out though. So, but thanks, Zach. It's been a great time. Everyone's questions and engagement's been great. Again, the whole thing is that it just makes our lives a little bit easier to use this. So that's my final parting wisdom.
Thank you. All right, guys, we'll see you on the next stream. Thank you very much for joining us.
Thanks, everyone.